So far, we have looked mostly at simple cases in which all the numbers involved in the calculation were either integers or all doubles. Here, we will see what happens when we mix these types in calculations. First, we have casting. C# will not normally store information in a variable if in doing so it would lose the information. An example of information loss would be if we tried to take an amount in a double and then put it in an int. This would cause an error because it would lose the decimal, and C# doesn't want to lose that. One solution for this is to force compilation by casting. This will still lose the decimal information, but it works. And we do this by putting an int in parentheses in front of the d. That tells C# that we want to cast this double as an integer in this particular case. You can also do it the other way around for a double, but casting does not work with strings. This requires parsing, which we'll learn about later. Next, we have mixed data types. The first thing to know about mixed data types is that you generally don't actually need to use a cast to take an int into a double. A double will already hold an integer, so you can just put it in there and C# understands what you're trying to do without any data loss. The next thing to know about mixed data types is that in a math operation involving two different data types, the result is given in terms of the more precise of those two types. So between an int and a double, it's always going to need to go into a double because the double can hold more information than an integer. If you're simply putting your math operation inside a console write line or something like that, it will always return a double if there is a decimal inside the math operation. So, for example, if we have 6.0, the 6.0 looks like an integer to us, but because it's written with that decimal point, it's considered to be a floating point number or a double, and that's how C# is going to treat it. Along the same line, C# is going to look at that 5.0 divided by 2 and return that particular part of the problem as 2.5, or a double, so the entire answer is going to become 12.5. However, if we go in and delete that 0.0, now it's going to do integer division with it, and it's going to drop the decimal. So if we run that program, we're just going to get a 12. In the case of casting, when we don't have a variable, if we put the int directly in front of something in parentheses, it's going to drop the decimal in whatever is in that. But it's going to use order of operations. So when we run this program, we're going to get -0.2. However, if we took out that int, of course we would get 0. Now, if we were to put the integer cast back in front of the first piece of the problem and go ahead and make that not a decimal, but change the 4 to a decimal in the back, it's going to ignore that int for the second part. It's going to follow order of operations, and it's not going to pay any attention. But again, following order of operations, if we put parentheses around that entire part of the program, now it sees all of it as integer division, and we get a -1 instead of the decimal answer. Now, along the same lines, in this problem, we make the 5 a double, so it's going to treat it as 5.0, and when we do the division, we get 1.25, because remember, it always goes to the most precise piece that it has. When we took out the double, we only got a 1 because it drops the decimal. And again, if we just make it 5.0, it treats it as a decimal without the cast. In this example, we can see that a little more clearly. When we divide double j divided by k, it treats the entire thing inside the parentheses as the first thing it wants to do in order of operations, so it becomes the integer. So you only get a 1. However, if we were to take that out of parentheses and put a double also in front of the k, it's going to treat j and k as doubles. And when you run it, you'll still get the 1.25 because it now knows that it needs precision for both numbers. The final thing we're going to look at for this lesson is the constant. Constant follows the same rules, some of the same rules as a variable. It has the same data types, it has the same naming rules, but we're going to use the keyword const, C-O-N-S-T, to indicate a constant in front of the data type. Conventionally, constant names have all capital letters, and once they're initialized, constants can't be changed. So for example, we all know pi doesn't change. So if we make pi a constant in our program and then try to change it, it's going to throw an error.